So, hello everyone, and welcome to the channel. This is the very first video of the course which we are bringing on. So, the course is regarding the data structures and algorithms, and straightforwardly, we are starting it out with a data structure known as linked list. And anyhow, we guys know that what is linked list, right? So, linked list is nothing but a linear data structures which are connected it out in a linear format, right? Unlike arrays, with the help of those pointers and nodes, we are doing it out. So since it's a your problem solving course, so we'll not go much into the theoretical part, rather than we'll be focusing on the problem solving part, right? So without any delays, let's get started. So I'll present my screen and we'll discuss one problem. So there is a problem known as remove nth node from the end of the list. So, what's the problem says? Let's discuss about that first, right? So, why I'm straightforwardly jumping it out into the deletion part first of all, because the insertion, deletion, and the traversals, right? Those are the very important part. And in this question, we will be studying how to traverse through the linked list. And at the same point of time, we will be solving the major, the motto of this problem, which is to remove the nth node, which is a specific node which will be given as an input, and then we'll be deleting it out from the list, right? So we'll see the problem. So the problem states that given the head of a linked list, remove the nth node from the end of the list and return its head. So in the given figure, as we are seeing it out, we are having a linked list which consists of 5 nodes: 1, 2, 3, 4, and 5. So now let us suppose if the n value is given as 2, that means that from the ending side, the second position, that means the last second position, that we have to delete it out. So the fourth node should not be present, i.e., it should be removed from the linked list. So the resultant list will be 1, 2, 3, and 5, right? So, but also let us suppose if you are having a node, only one node, and n value is 1. Since n value is 1, so if you remove it out also, you will not get anything, right? Because just like 4, if you are deleting it out, we are getting 1, 2, 3, and 5. In a similar fashion, if you are trying to delete the first node as per mentioned in the input, we will get null as a return value, right? So like this way, we have to, considering all the constraints in mind, we have to solve the question. So, since in this tutorial I have majorly focused on debugging as well, because as a beginner, right, most of the people will try to write down the codes after understanding the concepts, and they end up in writing some links in a wrong manner or in a weird fashion, due to which answers and all will not get it out. So, for this, I'm trying to use a Visual Studio Code. So, we'll write down the code there such that in an intuitively way we can try to debug it out and can understand, okay, whether we have done right or wrong. And then after writing it out here, then maybe we can pass it out into the lead code just to check it out whether in lead code side it is compiling or not, right? Okay, so let's get started. So since this code I am writing it out in C++, anyhow in Java also it's almost the same. Anyhow, you guys know it's a kind of syntax difference will be there in that. That's it. So let us make a the node class. Just we'll just try to make some the declarations, whatever the necessary declarations are there. We'll try to create some properties initially, which is nothing but int data, and this is node next, and since this is C++ side, we'll giving up star next for pointer. Now we'll try to initialize a structure, sorry, a constructor I mean. So node, we'll be trying to initialize the data. So we'll try to initialize this of data is equal to new data, and this of next is equal to null. So this is done. Now we'll try creating another class. Let's say operations, because we are performing some random operations, right? Since here it is a deletion case, I'm just trying to keep some, a generic name. Let's keep it out as an operations class, right? So now what we will be doing is we'll be creating it out one function name. So let us name it out as public void. Sorry, since this is C++, so we should be pretty much careful. Public void delete node. Let's give it out as a delete node function. And at the same point of time, we'll try to initialize the parameters or write the parameters as well. Okay. So since we know that we have to find out the linked list, I mean new linked list by deleting the a node from a specific position. So for that, what we require, let's try to understand first. So in this particular linked list, we are seeing that we are given an input value n is equal to 2, right? So that means from the ending, we have to find it out. From the beginning, if we would have to find, it was simple, right? Just try to write a loop, and then we can take a previous node value, and based on that, we can try to just change the link of it. But now, since it's an nth case and it can be any numbers, right? It can be any numbers. Either it can be n equal to 4, which means 5, 4, 3, and 2. In that case, we have to remove the second node. It can be a fifth node. In that case, we have to remove first node itself, right? So in this particular scenario, what is the best possible choices to find out the length of the nodes? So if we try to find out the length of the nodes, then we can easily subtract it with the input value so that we can get to know till what node we have to traverse such that we can get the hold of the previous node to the target node. Here the target node is 4. So we want to get the value of third node, right? We want to reach to the third node so that we can link the pointer to the last node, right? Which is nothing but fifth here, fifth node. So same way we will try to do it out. So let us try to create a function first. I'm sorry, I'm pretty bad in indentations, but it's fine. So let's try to create a function which is of type int. It will return int, and I will write it name as count nodes and node star of head. So now what we can do is we can take one counter variable, and since, as I said, right, traversals also matters. So here in this function we'll be studying about how to traverse through the linked list, and based on that we will try to count the length of the nodes present in the linked list. So what we'll do is we'll try to run a while loop. So until and unless head is not pointing to null, which means that I can point it out to the nodes, other nodes. So let's see 1. First node is here. Its next value will be 2. Its next value will be 3. Next value is 4. Next value is 5. And then after 5, fifth node, there is no other nodes present, right? So basically it will point out to null. So we will be running a loop until and unless head is not equal to null. And then at the same point of time, we'll try to count. We'll increment the counter value, and then we'll shift to the next node by writing head equal to head of next. Simple, right? And then at the end, we'll be returning the count. So here in this delete node function, first what we require, let's try to understand that first. So we'll try to create out a node uh, variable, node type variable. So we'll write cur equals head, which is done. And at the same point of time, what we can do is we can write a variable known as length, where the length of the nodes are being counted. So here you can write cur as well. It doesn't make any problematic thing for us. And now what we have to do is for I'll run a loop I less than, since the position is how much? Let's say this is second position, right? So what we will do is we'll run a loop till this range, less than this range, such that this part we will try to get the previous node part. What I mean is, let's say we are having a five nodes as a length, right? Five is the length. We want to remove the second last position, or the second last node from the linked list, which means 5 minus 2, which is nothing but third. Okay, but actually it's not third, right? Because when we are subtracting it out, we are getting like that. We need to think about the second node, which is nothing but the fourth node. So what we'll do is we will try to get access to third node, such that when if we are getting access to third node, we can just remove this link, and then we can point it out to the fifth link, right? So now what we will be doing is we'll write length minus n and then I plus plus, and let I starts from 1. So let's suppose if 5 minus 2 is present, okay, maybe let's complete the whole code and then we'll try to debug and understand. It will give us a proper understanding on how the things or the workflow is happening for the given code. So we'll do, and also we should define this case as well. Cur is not equal to null, such that what will happen is, in case by shifting the nodes, right, we will get to know whether the null had been encountered or not, because in that case we should not be pointing out to null, right? So it's done. Okay, so now let's see it out. Cur is equal to cur of next. So what will happen in this particular scenario? Let's try to understand this case. Or in case if you think, right, we should not write it down, make it out as a complex one. What we can try to do is simply we can write it down like this. If cur not equal to null, cur equal to cur of next. So let's try to understand the flow first in this particular case, then we'll try to understand the later part of the code. So we know that there are five nodes, right? 1, 2, 3, 4, 5, as we have seen in that lead code question. What will happen is, since the length is 5, right? Length is 5, and if we see the cur equal to cur of next we have given, right? So 5 minus 2 is nothing but 3. So if we start from the first node itself, so the first node will be there, right? Now then it will point to the second node. Then it will come to the second, I will become 2. So cur now will point to the third node, right? Third node, it will straight away point it out. And then after that, when I becomes 3, right, it will not execute, because 5 minus 2 is 3 and 3 is not less than 3, so it will come out of the loop. So in that fashion, we'll be getting access to the previous node, right? Because 5 minus 2 is 3. And since we are doing cur of next, which means I can easily get the previous node access. We'll see the later things in debugging as well. Now, what to do? Let's try to analyze. So we have some certain conditions, right? So the conditions is like, let us suppose, okay? Let us suppose if length is equal to n, if length is equal to n, which means what? Let's say we are having a linked list and its size is 3, right? Its size is 3. Let's go to the question for the diagram for the easy explanation. Let's see this one. So if you're having 5 nodes and if you are telling it out that I want to remove the fifth node, which means n is equal to 5, that means our linked list or the resultant linked list will start from the second node itself, which means 2, 3, 4, and 5, right? Which means it's obviously head of next. It's obviously head of next because it will be given this as an input, right? We should always try to do head of next. So this will be done. So whenever length is equal to n, we should try how to return. Okay, let me make it out as of type node star, which will be sounding better. And I'll try to return head of next. You can also write it down cur of next. No problem at all. And now we're gonna see the main part, how we can break out the link, right? So let's put some checks for safety sake. Like let's make sure like whatever we are getting it out, right? It's not null while accessing the value, so that we should not get it out anything wrong while accessing any nullable values. And then after that, what we can try to do is cur of next is equivalent to cur of next of next, and at the end we can try to return the head node because it will be modified at the end. So in that case there is no other issue at all. Now let's try to write out the function so that in this particular class itself only we'll be trying to print all the members of the linked list, right? So let's try to write a display function which will take head node as a parameter, and simple same thing again, we will be running out a loop head not equal to null, okay? And then after that we're writing out a cout just for a print sake. Okay, so we will be writing head dot head dot data, head of data, and then after that for another line, n head is equal to head of next. This is done. And now let's try to create out a main function, which is the ending part of this. Let's try to create it out. So I'll try to create out an object of it. So since it's C++, so we'll try to create a pointer is equal to new operations. But note, remember, we can try to do it out in a different way as possible. And since in lead code, we have to just write down the normal function, so it's fine. Display and all, we don't have to write it down, right? So now what we can try to do is we can just try to create some numbers, right? We can just try to create some data so that we can get to know how the things are happening or how the things are behaving. We can get to know like that. So now let's say I'll try to create out a node 1 is equal to new node. I'll write it down here as 10. This is done. Now node star of, or it's not required to create out like that. We can create it out node 1 of next is equal to new node of 20. This is also done. Node of next. Sorry, I think typo mistake. Equal to new node of 30. And in a similar fashion, one more. Let's try to create it out some dummy datas so that it will be easier for our understanding. More data, more better understanding. Next of next is equal to new node of 40. So as of now, we'll try to create out this many datas. And then after that, we'll try to create, or sorry, we try to call the functions obj of head. We'll try to pass node 1, and also we can just pass, let's say, 2, right? We can pass out the 2, that means the second node from the end. And then at the end of the day, just call the display function. So this will be done. If we call out the display function, then we are good to go. Let's remove the parameters, or else we can write it down here as well. Node star of head is equal to obj of this one, since I have already made as a return type as node type, so we can get this one. Let's pass it out the head as a parameter, so the display will happen. Let's try to build the code first. Let's see whether any errors are encountered or not. Okay, looks like it got succeeded. So we are getting 10, 20, 40. So as expected, we are getting the desired result, right? So if you're telling second node, which means 10, 20, 30, and 40, the second node from the end should get deleted off. And then as I said, we will start off with the debugging part so that it will be helpful for us to understand step by step, right? Let's try to put directly in the count nodes function and delete nodes function to understand how the flow is happening. So initially we were initializing it out the head, which is having data as 10, 20, 30, and 40 as you are seeing it out. Then after that, we are trying to get out the count of the nodes. Let's try to debug this as well. So head is not equal to null, which is correct because first node was a 10th node. That means the 10 value node. And then count will become what? Count will become 1. And then after that, what we are having, we are seeing it out, the end part, second node, third node, and the fourth node where 40 will get counted because next node will be null, so return count will happen. So now we are seeing it out, length is equal to n. Okay, so length equal to n, whether this is present or not, we need to see it out. So n was what, 2, right? So this will not happen now. So we went to here, length minus n, which is nothing but 2 as I mentioned. So the first loop, anyhow, it will point me out to the second node, right? From the beginning itself, I mean to tell. So if you see here, current is not equal to null, which is fine. Now current is pointing to the next node, which is nothing but 20, right? And I require the previous node from the target node. So here the target node is what? 30, which is the second last node from the end, right? So now if you're seeing it out here, cur of next is not equal to null, then what we will do is, since the current node was pointing it out to the previous node from the target node, which is nothing but 20. So what I will do is, its next node was 30, right? I will break the link. Now I will point it out to the node which is having data as 40. So if we come out of this, we'll be seeing 20 and 40 of our current node. So, but we will try to return head. Why? Because the linked list, this will contains 20 and 40, but this head will contain the actual data like 10, 20, and 40. So hence this is done. Okay. So I stop the things. Now let's try to run the same thing in the lead code as well to see it out whether it's working properly or not, right? So let's try to code it out. It will hardly take few minutes to see. Okay. So this is in Java. So why I'm showing this, because C++ we have already seen it out. Let's see the Java flavor of this problem. So same thing, I will do it out. I'll try to take out list node cur, and also I'll be creating it out one function for counting the nodes. Then I will be taking it out one variable as a parameter, which is nothing but head, which I'll be passing it out. Int count equal to 0. Simple coding. While head is not equal to null. In Java, we write null in small letters, while in C++, we write in capital letters. And we do count plus plus. And at the same point of time, we try to do head equal to head of next, so that it will point to the next node, as explained in the Visual Studio Code way. Now, we'll try to get the length of the nodes, since we are having length as a return value, which is nothing but count nodes. And let's pass cur node, and let's try to write down some conditions, like if length is equal to n, so we know that we can return head of next, which is fine, right? Now what we will do is we'll try to run out a loop same way which we have done it out. I less than length minus n ni plus plus. Now what we'll be doing is we will just check for the safety sake cur not equal to null, and we can point it out cur equal to cur of next. This is done now. Now here again some couple of checks just to ensure that we don't get any issues. My mistakes, and this is Java code, right? So I should write it down cur.next, and this will become head.next. Okay. Current is not equal to null, and current dot next, this should also not be equal to null. So what we can do is we can write current dot next will point to the next nodes, which is done. And then we can simply try to return head. So this is also done. Let's try to see where if we have done any mistake. I think I made mistake by writing 0. Okay. Now this seems to be fine. Let me remove some spaces as well. I'm very poor in writing, in handling the spaces. So yeah, we'll try to, okay, let's try to run the code. And if any issues comes, we'll try to analyze. Okay, head of next. Where we have done wrong. Okay, since we have came from C++, right? So I wrote in C++ way, but although we have to write in Java way. Okay, we are missing return statements. Done. So as we see, all the test cases are passed. So 1, 2, 3, 4, 5, if n equal to 2. So the fourth node is getting deleted. So it's becoming 1, 2, 3, 5, 1, 2, 3, 5. The case 2 also, as I explained. So if it is the first node, that means length is 1 and n is 1. The head will point to the next node, which is nothing but empty because nothing is present, right? And similar way in case of third case, test case, if 1 and 2 is present, we have to remove the first node, right? So we'll remove the first node from the end, which is nothing but 2. So it will become 1. Let's try to submit it and see the timings as well. Okay, so it looks like all the test cases have been passed. And yeah, that's it for this session. If any doubts, please do write in the comments.